Hello. We're now on to the free response solutions for exam one. If you watch the multiple choice solutions, you know that I will try to put up a little marker for you as we move through the problems so that if you don't want to watch one of them, you can use the thumbnail to scroll. Now, that being said, there was not a single person that got full credit on all of these. Like, if you're retaking, you probably need to watch the solutions for each one of these free response. I don't want you or anybody to be discouraged about your score, even if it was low, even if what you would have gotten translated to a 1. Because sometimes you learn the most when you make mistakes and you have to try again. And by sometimes, I mean like 99% of the time. This is not a time to be discouraged and doubt yourself and feel like you're a dummy and feel ashamed or feel like a disappointment. None of that. These questions are hard for me when I first look at them. I have to think about them. I have to struggle over how I'm going to word it. It is normal. And I'm not just saying that to build you up. I'm saying that because I'm being truthful. These are difficult problems. But if you persevere through that first part where you freak out because you don't know what you're doing, you will be able to figure these out. And I think once we go through them together, you will realize that. Preparing for the free response is super important. You want to do it. When I was a student, I would always not study the free response because they always were like, well, they're going to be different, so what's the point of me practicing them? They're all going to be different. No, no, no. Bad move, Miss Four. Bad move, Samantha. You got to practice the free response. So you guys overall did well on the multiple choice, but the free response, we kind of fell apart. So make sure that when you get the opportunity to do free response problems, you are taking advantage of those opportunities and actually trying. Now, that being said, I personally would recommend that whatever you got wrong, you get a big old eraser and you erase it all. Just erase it. On the multiple choice, it may be helpful for you to keep the one you got wrong and then select the one that you got right, especially if there was a reason you chose the wrong one. But on these, family, you might just want to be erasing the whole thing. If you don't want to erase, then you should get a separate sheet of paper and attach it, because when you come to take your retake, remember, you need to show me that you did these. When you take your retake, you need to show me that you did these, and they need to be very similar to mine. I don't necessarily want you to copy me word for word, but if you got it, you got it. Hopefully we understand what we should be doing here. So we're going to go through these. We're going to write down the correct solution, and we're not going to retake the exam until we truly understand the ideas in these problems, because they'll either show up in the multiple choice or you'll get another free response on it. So do the thing. Okay, I think I was going to tell you one other thing. I forget it. Okay, number 1. We have the caffeine problem. We have some popular beverages, which we've seen. You have the data for this. It's in your notes. We've dealt with this data set quite a bit. I've just translated the data set into a box plot. So they don't tell us, or do they? This is 12 beverages, and the box plot shows us the summary statistics for the 12 beverages. So one of the first things that I want to highlight is that this guy is definitely an outlier. That's not a question. He is an outlier. So when we look at this data set, we want to look at the box plot and just be aware that we have an outlier out here. Now, this says one popular gourmet coffee has over 300 milligrams of caffeine. What would happen to the mean and the median if you added this in? Explain how you could do this without performing any computations. So here is what they are trying to get you to highlight or recognize. The median is essentially a position. It is the position for which 50% above and 50% below. So you should not be writing this down at this point. Do not write these down. So this is the first thing that they want you to understand. The median is a position, but it has a value. It is a position, but it has a value. And in this case, the value is, I don't know, 49. So 6 of the observations are below 49, and 6 of the observations are above 49. So first of all, one of the biggest things is you need to understand that median is a position. We're 50% above, 50% below. So in this case, we have about 49 as our median. That means 6 observations below, 6 observations above. Okay, the mean considers all values. So now we know these are very different. This is one value and it describes a position. This takes into consideration all values. And because of that, it is not resistant to outliers. We do not know the mean of this data set. This guy is roughly symmetric. So I would say that the mean could be like 50 something. I think I lied here. Did I? No. The mean could be close to the median, but you got this outlier here that's probably going to make it so that's not the case. Without the outlier, this is roughly symmetric, and the mean would probably be close to 49. But with this outlier, And an outlier will always change your mean in the direction, it'll pull it in the direction of the outlier, but also this outlier is much bigger than your minimum value. The maximum value. This maximum value looks to be like 105-ish. This outlier is like 60 grams away. So not only do you have an outlier, but it is a large outlier. So this is going to increase your median. So what we know at this point is because it's not resistant to outliers, right now the mean is greater than the median. So this is your basic understanding that you need to come into this problem with. So what does adding a value of 300 do? Well, for the median, not much, because all it's going to do is change it so that your median is the 7th value, and then you have 6 below and 6 above. Now, do we know what that 7th value is? No. It could be really close to 49, or it could be closer to 60. We don't know what the 7th value is, but because it's just making it so that your median is the 7th value instead of between the 6th and 7th value, your median is not going to change by much, if at all. So I'm going to say that again. Because the median describes a location, it has a value, but it also describes a location. your median does not change by much, if at all. Because all that has happened is, instead of being between the 6th and 7th observation, the median is now the 7th observation. If that is not making sense, you need to come in and talk to me until it does. So, it's not going to change by much. It's not going to get significantly better, because remember, 49 is between the 7th value and the 6th. So when you bump it up to the 7th value, it's not going to be that far away, because the median is the middle point of the 6th and 7th. So the median's in the middle, and you're just going boop to the 7th observation. So it changes not much, if at all. Not much, if at all. Oopsie. Gotta make myself small. Not much, if at all. Okay, the mean, on the other hand, if we add in 360, just kidding, 300, well, that's twice as big as your outlier. Twice as big. In fact, is it more than twice as big? Almost. 2 times the outlier. And it is almost 3 times bigger than your maximum value. So your mean is going to increase significantly. Why? Because it considers all values. And what issue does that present? It's not resistant. So that means that an outlier is going to significantly affect the mean. How, when it says, explain how you would do this without performing calculations, my explanation is showing that I understand the median is a position, but the mean considers all values. This is not what I would write. This is the basic understanding behind your response. In your brain, in that span of time, in that span of 15 minutes that you have to figure out this problem, all of this needs to happen. Then you figure out how to explain that in your written response. So I am going to show you my written response. I would encourage you to take this understanding, pause this on the screen, and try to describe this in your own words. The things that you must absolutely show are what I am going to highlight. You need to know that the mean considers all values, and this is an issue because it's not resistant to outliers. If you get an outlier, it's going to change your mean. So these 3 ideas: considers all values, not resistant, mean increases. For the mean, you have to indicate that you know that 50% above and 50 below. So you're going to change to the 7th observation, which means that it's not going to change by much, if at all. It does not matter how you write it as long as you get these elements in. In fact, honestly, I would rather see this, and I think an AP reader would rather see this than you struggle over how to make a paragraph. So if you got to do it this way, do it this way. Okay, so let me show you my paragraph. Please, I just need to reiterate that. If your biggest struggle is writing the paragraphs, just write it out like I did. Because in that case, they can give you partial credit, if not at all, if not all credit. It's not pretty. It's not as pretty as a paragraph, but you know the information. Don't get punished because you can't write it in a nice paragraph. Write out all the information as a list and hope for the best. Okay, So here's my written response. I really think you should pause this and try to write your own though. Median will become the seventh observation instead of between the sixth and the seventh observation. It's possible the mean would increase, but likely it'll stay about the same. So that boils down to position will change, but median would not substantially change. Notice that I'm not making any bold statements like it will stay about the same. I'm saying it's likely to stay the same. The mean will increase because 300 is an outlier that is almost 3 times as big as the maximum value on the box plot. Mean is not resistant to outliers, so 300 will increase the mean. It would have been even better if I would have added in the mean will increase because it's an outlier, and when you calculate the mean, you have to add all of the data values. So that's why it gets bigger. This is full credit though. This shows that I understand the situation, and this highlights all of the things that I need to highlight to get full credit. And I've written it in a way that my explanation is in my response. Like some of you guys said, median will increase because of this, and mean will increase because of this. And you can do this without computations if you understand what the mean and the median are. Just, you don't have to say that, just make sure your reasoning is clear in your paragraphs. Okay, so pause that if you need it. Hopefully you wrote one that you feel comfortable with, and we will go on to numero dos. I'm just trying to find my 2 paper. Okay, number 2 is I'm thinking that once we go through these on all of these, you guys are gonna feel like, what, seriously? Okay, this is about the teacher student ratio, and I would like to highlight that this problem was given to you in the practice test, and in the practice test you were supposed to find the median. You were supposed to describe how you would use the histogram to find the median. And what you found in that problem was that the median for both areas is 15. That's what this statement here is telling you. The typical ratio is 15 pupils per teacher. What I told you there is that the median for the West is 15, and the median for the East is 15. So then they want you to explain, how do you think that the means will compare? How do you think the mean will compare? Well, family, the only case, or the one place where we've talked about how mean and median compare, is in relation to shape. If your shape is symmetric, they are approximately the same. If your shape is skewed, they are not. So you needed to recall, if they're asking me to compare the mean to the median, I want to look at shape. So why did I not do that in this problem? Because they're not asking you to compare the mean to the median. They're asking you what would happen to the mean, what would happen to the median. These want to know, or this problem wants to know the relationship. So that means I gotta use shape. Okay, well, the shape of the West, so I'm gonna write down what I'm thinking, this is not my response, is skewed right, which means that my mean is bigger than my median, which means that my mean is bigger than 15. the East is roughly symmetric. You got a little bit extra on the lower side. Roughly symmetric, if not a little bit more on the lower side, which means your mean and your median are about the same, which means that your mean for the East is about 15. Okay, well, if the West is bigger than 15 and the East is about 15, and if anything a little lower, because remember you had more values on the lower end, well, now I can say that the West is greater than the East. The West is greater than the East. So these ideas that I just wrote down are what you had to have for full credit. You had to show you knew these ideas. And ideally, you showed this. They gave you the mean. They gave you the median, so use it. Use the median. Use that value of 15. So now I will show you my written response, but just like the last one, I think that you should pause the video and try to explain this. And if you are struggling with the written responses, do a brain dump like I'm doing and just write down everything that you know. This is my reasoning. It says explain how you think they will compare. Well, this is my explanation for the West. This is my explanation for the East. This is my conclusion. The West is greater than the East. And all of those need to be a part of it. You need to clearly state skewed right, bigger than median, roughly symmetric, or you could say slightly skewed left, about the same as the median. Then explicitly say that means the West is bigger than the East. Okay, here's my solution. The distribution of the ratio of the number of pupils to the number of teachers in the rest is skewed right, so mean is greater than median. This little, like, weird smiley face looking guy means so it follows the mean is greater than 15. The distribution of the ratio of number of pupils to the number of teachers in the East is roughly symmetric, so the mean and the median are about the same, which means the mean is roughly 15. The mean for the West will be greater than the mean for the East. And then down at the bottom, I had to write a note to myself that for you guys to get full credit, you needed to use the shape of the distribution and the relationship of the mean and the median given that shape. Okay, so that's 2. Next up is 3. Okay, fam, this problem makes me so sad because you had this exact problem on your practice test, except for it was the graph we just did. Explain how you would estimate the median of these two graphs. And you have to go through and explicitly state the median is the value where half above, half below. Use N to determine where the median is. Use the histogram to determine the bin, and then describe doing that for the graph. You had this test question on your practice test, and you do it exactly the same as you should have done it on your practice test. I also gave you some opportunities to practice that with your multiple choice questions. Your multiple choice question, how do you find the median? The quartiles. How does the mean and the median relate? This is more for the last problem, but it would have helped you with that for your response. So on Number 3, you had to give the definition of the median. 50% above, 50% below. Which means you need to use N to find median. Use N to find median. So then you can use the position of the median. So for the first one, you end up finding that it's between the 100th and 101st observation. And then you need to describe why that matters. So I can add the frequency in each bin till I find the observations I need. Then label the histogram and say C histogram. You needed to describe that you were coming up here, finding the frequency in each bin, and identifying the bin that the 100th and 101st observation was in. It's not enough for you to just say it's between the 100 and 101st, and that is bin 4 to 7. You had to explain, I'm adding the frequencies till I find that. Then you say median is in bin 4 to 7. I might be lying. That one might be 7 to 10. And then you clearly needed to say, so A is 7. Then you could have just said, using the same method, median for B is in bin whatever it was in. So B is 6. So that's the brain dump. This is what needed to happen in your brain. You needed to clearly state 50% above, 50 below. You needed to clearly state A is 7, B is 6. And then between there, you need to describe as if the grader has the grader, the AP grader, as if they have no idea how to calculate median. You have to be that descriptive. You can't just say, I found the position of the median, though that position is in this bin, so A is this. You have to say the observations are this, or in between, or whatever it is. Use the histogram to add up observations until you find the bin, blah, 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 blah. Okay, I think that you get it. So I would challenge you to, once again, write this before I show you mine so that you have practice, because your free response are not going to be the same, but you never know. You might get one of these and then 2 different ones. You never know. Okay, here's my response. The median of the distribution is the value for which 50% of the observations, you probably want to see the words, sorry about that, fam, are below it and 50% are above it. If N is 200, then I need to find the value for which 100 observations are below it and 100 observations are above it. So the median will be between the 100 and 101st observation. I can add the frequency in each bin until I find the bin that contains the 100 and 101st observation. I should say each bin in the histogram. And then notice I say C histogram above, and then I show my work. N is 200. This has 46 observations. This has 48 observations. This has 24. So this means that 7 to 10 contains the 94th to 108th observation. So that means the median has to be in there. So A can only be 7. So the bin from 7 to 10 contains the 100th and 101st observation, so the median is likely 7. Using the same method, the median for histogram B is the 111th observation. The bin 4 to 7 contains the 100th observation, so it is likely that the median for high school B is 6. Boom. Okay, what number are we on? 4? Did I even put up the little signy do for 3? I don't think I did. Okay, now we're on the last problem. Oh, I did. I think a lot of you guys are going to be frustrated when you see the solution to 4 because he was actually one of the easier ones. So, you are looking at gas mileage, and this is something that I didn't know until I was older, but like at stores like AutoZone and O'Reilly and even Walmart, the automotive section, they sell liquid that you can add to your gas tank to give you better gas mileage. It's called an additive. So this is a real thing. You can add something to your gasoline every time you fill up your tank to help enhance the performance of your car in some way. So these, I don't know if it was the company or what, but we're comparing 2 additives. We're comparing additive A and additive B, and we're looking to find which additive increases gas mileage. Which additive will increase gas mileage? So they gather data on additive A and additive B, and how they did this was they drove the car around without the additive, and then they drove it around again with the additive. For each case, they recorded how many miles were driven and then subtracted them. So one thing that a lot of you guys were not understanding about this graph was that these values are the difference in gas mileage. So for a number like 9, that could mean that for with the additive, you got 39 miles per gallon. And without the additive, you got 30 miles per gallon. So the difference is 9 miles per gallon. That 9 represents you got an extra 9 miles per gallon with that additive. Now on the negative end, this could mean with the additive, you got 20 miles per gallon, but without the additive, you got 30. So the difference this time is negative 10. You got less gas mileage with the additive. So down here where it says label the graph, you would use your maximum and your minimum values as your guide. So looking at these values, this top box plot has to be A, and this bottom box plot has to be B. And then you need to label your axes. But none of you, that's not true. 3 of you out of 60, 70, 80 plus students, 80 plus, labeled this right. This is the difference in miles per gallon. And you need to say it is the with subtract the without. So I think that's the first place where this problem went wrong. You needed to understand what this graph was telling you. B, which additive would you recommend if the goal is to increase gas mileage for the highest proportion? So number one, we're looking at increase gas mileage. Number two, you're looking at highest proportion. Proportion always means fraction or percent. Fraction or percent. Okay, well, on this graph, an increase in gas mileage is any situation in which the difference was greater than 0. So I'm marking that on this graph. So everything to the right of that orange line represents an increase in gas mileage. Remember, positive numbers mean you went more, negative numbers mean you went less with the additive. So now we use our knowledge of box plots. So I can say for this top one, 75% had an increase. And more than 75%, but I only feel safe doing 75 because I don't know if this is 80 or 82 or 85. I have no idea. So I'm going to go with what I know for sure and say 75% had an increase. But for B, only about 50% had an increase. How do I know? Because of the sections of the box plot. This is 25, this is 25, this is 25. This is 25, this is 25. So which one would I choose? A, because 75% had an increase, whereas only 50% of B did. Now this is not my formal response, this is just my brain dump. I'll show you my formal response in just a moment. Okay, next up is which additive would you recommend if the goal is to have the highest mean increase? Well, we don't know the mean, but we do know median. They want you to use the median to estimate the mean. They are wanting you to recognize you're doing mean versus median, which means you need to look at shape. So we go back up to our box plot. This guy, A, is left skewed. B is definitely right skewed. So that means that for A, your mean is less than 3, and for B, your mean is greater than 1. How do I know these values? Because I highlighted them in pink up here. So the first step is knowing these things. The mean is less than 3. The median is greater than 1. Well, the other thing that you need to consider is that B is probably going to be much greater than 1. Why? Because it is so right skewed. Your values go all the way up to 40. You have data values, half of your data values are between 0 and 40. So not only is it going to be bigger than 1, but it's probably going to be much bigger than 1. So if A is less than 3 and B is much bigger than 1, if you want the biggest increase, mean increase, because it says highest mean increase, you're looking at B, because B will have a bigger mean because of its right skew. And A is left skewed, which means its mean is going to be less than 3. Okay, now let's look at how we would word that response. So I just noted on mine that an increase of gas mileage means the difference is greater than 0. I would recommend additive A. About 75% of the cars assigned additive A showed an increase in gas mileage. Only about 50% of the cars assigned additive B showed an increase in gas mileage. B, the distribution for additive A is skewed left, and then I gave the same values that I gave. The distribution for additive B is right skewed, with 25% of its values greater than or equal to 25. So mean is greater than median, which means your mean would be bigger than 1, and likely greater than 3 because of the larger values above the third quartile. I would recommend additive B because its mean will be greater than the mean for additive A. So that's all she wrote, literally. Hopefully these free response solutions help you, and if you're feeling like, oh duh, I am so mad right now, that's normal. That's normal. Just remember, when you go to retake this exam, I am not going to give you a problem that you don't know how to do. So if you're struggling, that means you don't understand the problem, which means you need to read it again until you're like, oh, okay. Because if you would have understand what the box plot was asking you, I feel like all of you could have answered it. There's honestly, I mean this with muy mucho, so much love, there is honestly no excuse for the high school problem. If you got the high school problem wrong, what you doing? You had that in your practice exam. Similar with number 2, I feel like you were prepared for that, and even number 1. So make sure on your retake you remember multiple choice and free response. You remember, I'm not trying to give you problems you don't know how to do. I am giving you problems that you know how to do. So if you're struggling, it's because you don't understand the problem. Read it again. Okay, so that's it. Write it all down, bring it all in. Any questions you have, bring it in, email me, send me a video, we'll figure it out. You got to retake by Friday, 10 a.m. You got to be here as the latest you could be here. All right. Love you.